Hi everyone, this is another day of factoring before we get to why we factor, and today we're factoring trinomials that have a leading coefficient other than 1. Before we get there though, I just want to do a little bit of reviewing with you because you have to know all ways to factor. So let's look at this first one. You have sort of like a checklist that you should go through when you are factoring, and the first thing you should always look for is a common binomial. So you're going to look at each of the terms. Do they have anything in common? Well, they have a 2 in common and they have an x in common. So we can divide out a 2x. That would leave us 2x to the third minus 12x squared divided by 2x is 6x, and 18x divided by 2x is 9. And then you can check to see if there's anything else that you can do. And right now we don't know another way to factor this portion of it, so it's as factors as it can get. All right, question 2. Is there anything in common? No. Is it a special case? Well, it is a binomial. It does have a subtraction sign, and both terms are perfect squares. The square root of 16x squared is 4x. The square root of 25 is 5. So we can factor that as a type 1, where it is the sum and difference of two terms. All right, 3. Do they have anything in common? No. Is it a special case? Well, it's not a binomial like this one. It is a trinomial though, so we're going to check that type 2. Are the first and last perfect squares? Yes. And is that middle term twice their product? Well, 5x times 3 is 15x, times 2 is 30x, so that is its factored form. And lastly, 4. Is there anything in common that we can factor out first? No. Is it a special case? No, because 33 is not a perfect square. So, does it fit this pattern? Where you have the x's as your first term, two numbers that multiply to 33 and add to 14. Well, 11 times 3 is 33, and 11 plus 3 is 14. So that's its factored form. So what we're doing today is factoring a trinomial, a quadratic trinomial, but where this leading coefficient is something greater than 1. All right, so I want to remind you that factoring trinomials is just working backwards from the FOIL method. So if we were to use the FOIL method here, we would do 2x times x is 2x squared, 2x times 10 is 20x, 3 times x is 3x, and 3 times 10 is 30. And then we can combine these middle terms to be 23x. So what we're going to be looking at today is working from this, where it is the quadratic trinomial, to see if we can split this middle term, in this case 23x, into its two different parts to represent the outer and the inner, so we can get to this form. So we're going to be working from here to here to here, with an added step in between. So there are a couple different ways to do this, and probably the one that takes the least amount of thought but the most amount of work is the guess and check method. So to do the guess and check method, you factor the first terms. So 6x squared could be 6x and x. So all we're doing is coming up with our first of the FOIL method. Or it could be 3x and 2x. So we're not sure yet which one of these we would use. Then you factor the last term. 12 can be factored in many different ways. 1 and 12, 2 and 6, 3 and 4. Again, we don't know which pair makes up our last terms, but we know it has to be one of those. So bottom line is, after you factor the first and the last, you just test out the different combinations until you find the one that adds to the middle term. So we could have 6x plus 1 times x plus 12, or we could have 6x plus 12 and x plus 1. Keeping with the 6x and the x, we could have 6x plus 2 times x plus 6, or we could have 6x plus 6 and x plus 2. And again, the reason we can have these, we don't know which one is right, but all we did was we know that our first term is 6x squared, so 6x times x is 6x squared every time we get that first term. And 1 times 12 is 12, 12 times 1 is 12, 2 times 6 is 12, 6 times 2 is 12, and then we can match up the last, the 3 and the 4. So we could have 6x plus 3 times 6x plus 4, 6x plus 4 times, oops, this was supposed to be an x plus 3. So again, right now, all we know is that we have the first and the last term correct. And what we'll be doing is checking that middle term, the outer and the inner. So here, the outer is x, and this is clearly not 17x. So 2x and 6x is not 17x. So all you're doing is checking 36 plus 2, that's not it, 6 plus 12, that's close, 18, but that's not it, 24 and 3. All we're doing is checking the outer and the inner to see if we have our middle term. So you can see how very tedious this is. And I could go on, but I think you get the point, at least I hope you do, because after we check all of these and they don't work, so this last one is 18 plus 4, then we have to go to the 3x and the 2x and match up all of these different possibilities. So we could have 3x plus 1 and 2x plus 12. And again, we know that the outer and the inner make the middle term, but we know that 3x times 2x is our 6x squared, and 1 times 12 is 12. So we know we have the first and the last. It's just that middle term that we're looking for. So I usually, if you choose to use this method, I usually list all of the possibilities in some sort of order so I don't miss any. So 3x, so I did my 1 and 12. So now I'm going to do the 2 and the 6. And then remember, you have to reverse it because you don't know yet where the 2 and the 6 go in, etc., etc., etc. So for the sake of time, I will let you sit and figure all of these out, but I want to go ahead and show you a different way because this is very tedious. All right, so here is the same exact problem we were just working with, but now I'm going to use the grouping method of factoring. I have the steps right over here. The first thing we're going to do is draw an x, and it needs to be a fairly good size x because you're going to be writing in it. Okay, then you're going to put the product of the first and the last terms in the top section. So if we multiply 6x squared times 12, we come up with 72x squared. And then we're going to put the middle term in the bottom section. So here's my middle term, so I'm going to put it in the bottom section. After this, and I told you to train your brain, because now you're looking for the two numbers that make this sum and add to this, just like snappy factors. So two numbers that multiply to 72 and add to 17, we could list all of them out and test them, but I know that it is a 9x and a 8x. So now that you have this, the two middle terms, use these two as our outer, inner. So we were before testing the outer and the inner, but now we know what they are. So we're going to rewrite our first term, 6x squared. We're going to use the outer and the inner. And in this case, I'm going to put the 9x with the 6x because it looks like there's more that I can factor out because they have a 3 in common. And I'm going to put my 8x with the 12. So now I'm going to, after I use these two terms as my outer and my inner, I'm going to group factor. So you have to watch examples, and I have plenty of examples. So I'm going to group. I'm going to group the first two together and the last two together. Now I'm going to factor. What do these two terms have in common? They have a 3 and an x in common. So 6x squared divided by 3x is 2x, and 9x divided by 3x is 3. Or you can think 3x times what gives me 6x squared, 3x times what gives me 9x. Now I'm going to do the same thing for the second group. They have a 4 in common. So 4 times 2x is 8x, 4 times 3 is 12. And now, this is where I like to say, okay, now I get to do a happy dance, because you know you did it right. You did this factoring right if these two are exactly the same. Because now we grouped, we factored. Now we're going to factor out this expression. So if we factor it out, 2x plus 3, because it was the same in both, we're left with, we factored this out, we're left with our 3x plus 4. So when we were factoring using the guess and check, we knew a possibility was the 2x and the 3x. We knew a possibility was that 12 was factored 3 and 4. We just didn't know the combination. So now we can double check. 2x times 3x is 6x squared. 3 times 4 is 12. And then I'm going to test my outer and my inner. 2x plus 4x is 8x. And 3 times 3x is 9x. And that gets me my middle term. So this is my answer. So I have many examples, actually 4 examples, because I think that it really does take some practice to wrap your head around this method, even though that it really is the easiest. So the first thing we're going to do is draw our x. There's our x. We're going to multiply, so we're going to take the product of the first and the last. So 3x squared times 10x is 30x squared, and we're going to put it in the top. Then we're going to take the middle term and put it in the bottom, so 17x. So now we need to find two numbers that make those snappy factors, that make this sum and add to this. So we can think of our factors of 30, 1 and 30, 2 and 15. Oh, 2 plus 15 equals 17. So I'm going to put my 2x and my 15x, and I'm just going to double check. 2 times 15 is 32, plus 15 is 17. So now I'm going to use these as my outer and my inner. So I'm going to rewrite my first term, and I'm going to rewrite my last term. And I'm going to make a wise choice, and it doesn't matter, but I'm going to put my 15x with this, because it looks like there's a lot to factor out. And I'm going to put my 2x with my 10. Again, you can get the correct answer regardless. All right, so now we use these as our outer and our inner. So we're going to group and then factor. So 3x squared and 15x, what do they have in common? They have a 3 and an x in common. So that leaves me with x plus 5. And the 2x and the 10, what do they have in common? They have a 2 in common. And that leaves me with x plus 5, because 2 times x is 2x, 2 times 5 is 10. So now again we can do that happy dance, because we have an x plus 5 and an x plus 5 right here that we can factor out. So here is an expression, here is an expression. We can factor out an x plus 5 from both. X plus 5. And what do we have left after we factor them out? We have a 3x plus 2. Always take a second to double check. So I'm not going to write it, I'm just going to say it out loud. X plus 3x is my 3x squared. X plus times 2 is 2x, plus 15x is my 17x, and 5 times 2 is 10. So I know that this is the correct answer. Example 3. Again, we're going to start with our big X. We're going to take the product of the first and the last. So 2x squared times 1 is 2x squared. And my middle term is 3x. So I'll put that right here. Now, what two numbers add to 3x but multiply to 2x squared? 2x and 1x. So those are going to be my middle terms. So I have 2x squared and my 1 down here, and I'm going to split up my middle term to 2x, and x. Then I'm going to group. I have a 2 times, oops, I can factor out an x in there as well, so x plus 1, plus, here they don't have anything in common, but we need another term here. So here's my x plus 1 right there, but what times x plus 1 gives us x plus 1? 1. So I can factor out my x plus 1, and I'm left with 2x plus 1. And of course, double check. X times x is 2x squared. X plus 2x gives me my original 3x, and 1 times 1 gives me 1. Okay, what I would like you to do for this last example is pause and try it on your own. But I want to give you the heads up that there's a little tricky part with the negative. But draw your x and see if you can put all of the pieces in the right part, see how far you can get before you start playing again. So pause, please, and see if you can do this on your own. Okay, I hope you really paused. I paused. I forgot that this was just pause, so I paused. So hopefully you got this. First thing you needed to do was draw your x. Then you needed to multiply the first and the last. 2t squared minus 10 is a negative 20t squared. And then you have to take your middle term, which is a negative 1t. And I'm putting that negative 1 in there because I'm a visual and I like to see, okay, my number really is a negative 1. So now what two numbers multiply to a negative 20 but add to a negative 1? Multiply to a negative 20, add to a negative 1. So since the product is negative, we know one is going to be positive and one is going to be negative. So 1 and 20, 2 and 10, 4 and 5. 4 and 5, if one of them is negative, that would be the difference. So it is going to be 4 and 5. 1 we know has to be negative, and since our sum is negative, the bigger number has to be negative. Okay, so now I'm going to rewrite my first term. A common mistake, by the way, is writing these as my first and last. Remember, you're going to that original. So you're not writing negative 20t squared. You're writing that original first term and the original last term. And you're just you use this x to find your middle terms. Now I'm going to put my 4t with the 2 and my 5 with the 10, just because it seems like the 5 should go with the 10. Again, if you don't, you should still get the same answer. Plus 4t minus 5t. All right, so now I'm going to group. So this part right here, this first part, they have a 2t in common, which leaves me 2t times t gives me 2t squared, and 2t times 2 gives me 4t. All right, and this is the part that I said might be a little tricky. We know after the last three examples what we're really looking for in the parentheses over here is a t plus 2. But if I look, this is a negative. So many times you need to factor out a negative as well. So I am going to factor out a negative 5. Negative 5 times t gives me a negative 5t, and negative 5 times a positive 2 gives me a negative 10. So now they do have the t plus 2 in common, and what I have left is a 2t minus 5. And I know that the way I wrote it, there's a little bit of space here, but really this should have been moved over, just so you could see that you really are multiplying. So now to double check, t times 2t gives me my 2t squared, negative 5t plus 4t gives me negative t, and t times negative 5 gives me my negative 10. So you draw your x, you put the product of the first and last, you put the middle term, you find what two numbers multiply to this and add to this. You use those as your middle term, you group, and you see what you can factor out, and sometimes you have to factor out a negative. I know on your assignment you have to do that a lot. Okay? Let me know if you have questions. One last thing, I guess, before I let you work. Don't forget about the discriminant. We haven't talked about it in a few weeks. The discriminant is part of the quadratic formula, the b squared minus 4ac. And I want to remind you that if that turns out to be a not perfect square, then you can't factor. So for example, if you had 2x squared minus 8x plus 1, and you plugged in the a, the b, and the c, and it didn't come out to be a perfect square, it wouldn't work. So negative 8 squared is 64, minus 4 times 2 times 1. So 64 minus 8 is 56. 56 is not a perfect square, so this is not factorable. All right, so that's it. Let me know if you have any questions.